Well, thank you very much. This is a tremendous honor, and certainly being part of a tradition that includes the amazing previous recipients of this prize is certainly more than anyone can reasonably expect, I think. I'm grateful to the Harvey Prize Committee and to the Technion for this recognition. It's a pleasure to be able to come to receive this at the Technion, which is the home institution of so many colleagues whose work I admire very much. And I'm grateful also to a large set of people for their support over all the course of my work, to my family, to an amazing set of mentors, colleagues, and students, and to the institutions, funding agencies, and foundations that have provided such a rich professional environment in which to take part in this whole enterprise. I think those of us who engage in science quickly come to appreciate how it's really this very highly interwoven activity with a mix of different generations, different perspectives, different institutions, all coming together. And as with other great collective human endeavors, it's a system that's able to accomplish impressive things. And so I think while we may highlight this or that part of it at different times, it's really this collective energy that's pushing things forward. And maybe that's how we should think about an award like this, as a way to focus in on a particular part of the whole and to ask what's been going on there. And if we were to ask that question, in my case, we might be led to two themes in the field of computing over the last 20 years, each involving the insights of this large professional community that I've been very pleased to be able to be a part of. First, the ways in which computing technology has helped people to create and share knowledge. And secondly, the ways in which computing technology has helped people connect in new ways with each other. Right? Knowledge and social interaction. These are, needless to say, integral parts of one's everyday experience. And computing technology, I think, has brought about huge changes in them scientifically, intellectually, and in our everyday lives. And the consequences of these changes are still very far from being worked out. So in keeping with the plan for this event, let me say a couple of words about each of these two themes: computing as a way to create and share knowledge, and computing as a means for social interaction. So let me first start with creating and sharing knowledge. And I'll try to tell the story about each of these using just a couple of visual aids, actually a total of 8 pictures that I'll try to walk through. So I entered the field of computing at the start of the 1990s, at the very beginning, just as the World Wide Web was beginning its meteoric rise from an academic project to a new medium of global proportions. And in the first few years of the web, it was sort of hard to know what to make of it, right? It sort of looked like this. There's a screenshot of the Mosaic browser from 1993. And Chief Scientist Avi Hassan, in his remarks earlier, pointed out the difficulty in recognizing which innovation to bet on and the reason to maintain a diversified portfolio. And I think one way to sort of internalize that in my case is to sort of note the fact that when I first laid eyes on the screen of the Mosaic browser, it was, you would have hoped that there would have been a flash of light and a thunderclap, and I would have realized this is the future. But as with many innovations, when you first see them, you say, okay, that's interesting, and you sort of move on. But in fact, of course, the web quickly, through the support of professional communities, the open source community, funding agencies, groups around the world grew very, very rapidly. At the start of 1993, there were 50 machines on the internet that would respond to an HTTP request. Within about 3 years, a large fraction of all the backbone traffic on the internet was web traffic. But in those first few years of the web, there were a few forces that were out of balance. On the one hand, people around the world were beginning to put a lot online, to engage in this amazing outpouring of self-expression in every conceivable form. But on the other hand, while the production of this information was well underway, the consumption of it was lagging behind. Right? So if you were using the web 20 years ago, typing things into that browser screen, then it was certainly this fascinating and serendipitous experience, but it was sort of haphazard. Right? It was like exploring a sort of warren of twisting streets, discovering amazing treasures along the way, but without any kind of map to guide you and without any global way of orienting yourself. To find out what you actually wanted online, that was the problem of search. And in those early days, 20 years ago, in 1994, it wasn't clear exactly how to think about search or really to understand how hard it might be. This is a problem you bump into in computer science. You write down a list of things that you'd like to accomplish using computing. And some of them are doable, and some of them turn out to just be monstrously difficult, and sometimes hard to tell which is which. Right? And in particular, web search was very similar to other tasks that even today computers have an incredibly hard time doing. For example, to simply take a document and summarize it for you, or to answer a few simple questions about it. Right? We've seen recent breakthroughs only in recent years. In 1994, those things seemed very, very far off. And so how should we think about search? right? Is it going to be like that, or is it going to be like something else? And we had this feeling that what you really wanted was a map of the web. You really want to be able to see it in new ways. And this metaphor of seeing, I think this is one of actually the many links maybe between the remarks that Professor Corkum and I might be making. I think a lot of science in a lot of different directions, as it sort of pushes at the boundaries of things, invokes this metaphor of trying to see things that are currently invisible to you, trying to find new ways of seeing. Not literally seeing, but in some metaphorical sense. So a map-making activity, that's kind of what we needed. We needed a map of the web so we could orient ourselves, and maybe then think about the search problem. Now, in fact, the next 7 of my 8 pictures will be, in some sense or other, maps that we tried to draw of the web. Although the first will be a map of physical space, just to remind us what maps look like. There's one. And the point is to sort of think about all the ways in which a map of the web would have to be different than, say, this campus map of the Technion. Because a couple things. One is, of course, this is a map of something that has physical reality, right? So the thing on the map here that shows the building we're standing in corresponds to this physical object that we're actually standing in. A map of the web will have to be different because these web pages were sort of notional. They were files on computers that you could read. The map has to somehow capture that disconnect. And secondly, the constraints of the physical world mean maps can only get so complicated. Right? Even a map of the most complicated place you've ever tried to walk or drive around is constrained by the geography of the world. But the whole power of the web, the whole thing that excited us about it, was the whole thing that made this enterprise so difficult. That there were no physical constraints. I could link to anything at all that I wanted, and we got this incredibly this tangled mess. But it was these links that somehow made the problem approachable and made it more tractable than some of these incredibly hard challenges that computing still has yet to tackle. Because the web is not just a collection of freestanding pieces of information that I encounter one at a time, as my browser might have me believe. Instead, it's explicitly linked with references from one web page to other web pages. Right? I include a link between one thing and others. So for example, when I author my homepage and say I'm a professor at Cornell University, I can create a link from my page to Cornell, and that orients me in that space of information, and to some extent Cornell as well, by creating that connection. And with many, many connections, it can actually impose some structure on this. And in this type of structure, of course, the web draws on a bunch of earlier intellectual traditions, not just going back into early computing technology, but much, much earlier, to the ways in which reference works and scientific papers and religious texts were explicitly linked by cross-referencing and citing each other. And this linkage turns the web into a network of connections, where it's not just a bunch of web pages floating in space, but we can actually see the explicit structure that's imposed on them. That's the first step in drawing a map, and as you can see, it gets us maybe halfway there. Because when you draw even a small piece of it, you get this aesthetically stunning tangle of spaghetti, which is links among blogs on the web in this particular case, a picture by Matt Hurst from 2007. But this is the key to beginning to understand the search problem. Because if I go back to the question of finding what did you really mean when you went to that internet search engine and typed in Cornell University, I can begin to follow where the links lead. Right? I take the part of the web that talks about Cornell, and I follow where the links are showing. And with some methods, and in the time I have here, I won't be able to go into what those methods are, I actually push the search forward across the links, and those links tend to flow toward the center of the query. Right, toward these bright spots on the map, in this case, for example, toward the homepage of Cornell University. And that, in the end, was the beginning of the field's current approach to search. And I think there are sort of 3 points that are useful to notice about that approach. Right? The first point was to let the accumulated mass of data speak for itself, rather than approach this problem by having a small collection of human experts curate the information and impose their own domain knowledge on it, which would have, obviously, the advantage that we could draw on human expertise, but the limitations that it would come with human biases and an inability to scale to 1 billion web pages. We didn't do that. Instead, we let the answers to web search emerge bottom up from the accumulated mass of the data itself. This is, of course, a theme that we now see in many, many fields of human endeavor, right? From targeted recommendations and marketing to data-enabled scientific discovery. It's the way that large amounts of data are beginning to be used to induce these answers bottom up in many, many cases. The second point is that large data sets often have networks embedded in them if you know how to look for them, right? To look for patterns of connections and to use those patterns of connections in some way that imposes structure on the problem, and then to use that structure for some kind of solution. And the third point is that in the end, what we were getting out of the web through search was only what people had already put in. we were able to find the answers to what people wanted because other people had already encoded that knowledge in a latent way through their authoring and linking of web pages. And it was really the job of these computer algorithms to get that information back out. And that leads to the final thing I want to discuss, the final half of this, which is the way in which the internet and the web have enabled new types of social interaction between people. So if we think of the web as having had this public presence for 20 years, right, maybe 1994, 2004, it's been on the public mind, then it is fair to say that the working metaphor for the web in the first decade, 1994, 2004, is the one I've been describing, this vast universal library of all human knowledge, all of it put together, all of it linked and cross-referenced, just as libraries of old had been. But starting around 2004, something interesting began to happen. And it happened really with a sort of speed that surprised us. And it took us a while to really realize that it was a profound change. And that was that the people actually began to step out from behind their web pages and interact more directly. Around 1999 or 2000, I would go and give talks, and I would naively say things like, the web is sort of a social network. And I would get criticized by social scientists who say, no, it's a collection of documents linking to each other. But I sort of felt like, yeah, but there are people behind these documents, and those links are really their attempt to interact with each other. And I think that's really what began to happen at an accelerating pace beginning in 2004 or 2005. An explosion of new sites came to prominence in roughly this period, built on technology that enabled direct social interaction on the web, from the kind of collective knowledge creation of Wikipedia to the sort of uploading and media sharing that you saw on Flickr and then YouTube, to the kind of direct social networking and sharing that you see on sites like Facebook. And so we began to think about a new metaphor for the web. It was not just a static library with a lot of information, but we began to think about the metaphor of the crowd, this teeming mass of people engaging with each other, reacting in real time to events as they happened. And this, I'd argue, is how we experience an event today. Something happens, we go online to find out about it, and we experience it from millions of fragmented individual perspectives from the crowd that exists online, from the tweets and the posts on Facebook, the uploaded photos and the videos. All of this is contributing to our understanding of the event. It's, again, an amazing bottom-up experience where we have to let the data speak for itself. And the computational challenge at the heart of all this, and it's really a profound challenge, is to assemble the meaning of an event as a coherent whole, the way we think of it, from all those millions of fragmented perspectives, all of them incomplete, all of them being put together. And so my next picture, I just wanted to show you a simple example to show somehow the latent power in this bottom-up view of things. This is some work that I did in 2009 with Dave Crandall, Lars Backstrom, and Dan Huttenlocker. We were looking at sites where you can upload photos. Think Facebook, where you upload photos, although at the time Facebook was much smaller. We were working with the photo sharing site Flickr. And every time you take a photo and you use the map interface, or if your phone has a GPS in it, then it puts a dot on a map somewhere, the latitude and longitude where you took that photo. And so we thought to ourselves, wouldn't it be interesting if you tried to just put a dot for every photo that was taken on the face of the Earth, right? So that's the idea. Start with a blank canvas, like the one I've drawn here. And every time there's a photo with a latitude and longitude, resolved very finely, we're going to put a white dot there. That's all we're going to do. And we thought, wouldn't it be interesting if shapes began to appear, and what would those shapes look like? So we did that, and some shapes started to appear. And that's what the shapes looked like. Now, there are a few things to notice about this also. First of all, the fact that you see a map there is, in a sense, in your own minds. This is simply a bunch of white dots on a screen where people took photos. But it is certainly the case that people take more photos in areas with very high population density. It is also the case that people take photos up to coastlines, and then, unless you're in a boat or an airplane where you're snapping photos out the window, you take fewer of them. And so you can see those boundaries. It is also the case that Flickr is not used uniformly around the world. There are parts of this map where there are a huge number of people, they're simply not uploading photos to Flickr. And of course, we see these other things, right? That strangely black region where the Black Sea is, that stringy thing where the Nile River is, that band of dots where mainly actually affluent Western tourists fly to go climb tall mountains in the Himalayas and take pictures of them. We see a lot of things from this one collection of dots. We're inducing a whole bunch of knowledge bottom up. No one person, when they stood there to take a photo, was planning to contribute to this map or to our understanding of the world, but collectively, in some sense, they all have. And this exists at many scales of resolution. I can zoom into that map. I could pick one of those bright dots. I could go into London, for example. And in fact, if I zoomed in, I would see the curve of the Thames River, and I would see all the footbridges across it. Every time anyone stopped to take a picture, it contributed to that map that was being built. That's what I'm thinking about by inducing knowledge of an event or a place bottom up from all of the data. Now, the management of all these online crowds is becoming a fascinating new computational challenge in and of itself. As people go online, trying to manage the experiences they have, trying to help them filter information, connect with each other, problems of human attention, of reputation, of incentives, all come into play. And much of it is built on an underlying bedrock of social networks, right? And this is one more map I wanted to show. This is going to be a map of a terrain that we visualize a lot less, although we deal with it on an everyday basis, which is the terrain of our social lives. So here I'll also put down a bunch of dots. But this time it's going to be a person, actually a guy who works at Facebook who donated this data for the scientific study. A dot for him and a dot for all of his friends. And a link connecting each of his friends who are themselves friends. Right? So think of all your friends, imagine them all out there in a map, and connect every two who know each other. Not all your friends know each other, but some do. And if you did that, you would get another picture. That picture would look like this. And actually, almost everybody's social network looks something like this. Having looked at a lot of them, at a global level, there's sort of less variation than you might think, right? So there's the Facebook engineer at the center. These are all his friends. And what you can see, for example, is that that thing at the top, that very dense patch of things, is clearly a bunch of people who all know each other. Right? That's a bunch of friends from one context of his life. And over there on the right, at about 2 or 3 o'clock, is this other big cluster. But that's a different part of his life. And those two parts don't really interact very much. And we see other smaller clusters arrayed around the lower left, right? Smaller groups. The one at the top is, in fact, his coworkers. The one on the right is his friends from college. A smaller one in there would be his family. And there are many, many other fascinating things in this picture. And actually, in my colloquium talk on Thursday, I'll actually essentially start from this picture and tell you some of the other things that we tried to discover, including the identity of the person at sort of 7 o'clock in the picture in the lower left. Okay, so again, the same sort of things happening. Masses of data trying to let the information emerge and finding networks hidden in them, in this case, networks of friendship and of interaction. Okay, so those are the two themes I wanted to talk about. I wanted to just wrap up with a couple of questions that I think there are many, many questions here, many exciting things to think about, and I'll just focus on 2 big themes that I think are clearly attracting a lot of attention from the community. So the first is about the question of, they're both questions about data. The first about the issue of stockpiling this much personal data. And in some sense, it's hard to cover the territory I've just covered and not ask questions about individual privacy and about the potential threats from accumulating this much data about people in one place. And that is an extremely important question that people in academia and people in industry, including the companies that power these websites, are thinking about actively. Thinking about ways of trying to balance these phenomena. The way in which people want to connect with each other, want to use these tools, and yet we want to protect their privacy. But of course, it's also the case that there are enormous potential opportunities in this kind of data, right? To let people reflect on their own data, right? Help them build tools or help them use tools that can let them learn things about themselves and potentially help them make better decisions. Better decisions perhaps about their health, about their time management, about their finances, about many things where you can possibly have software that can help you detect subtle patterns in your behavior and potentially act on them. So just to give you a picture of what that might look like, here's a picture I assembled very quickly from roughly 15 years of my saved email. This is studying one's own email, of course. It's hard to do without inducing sort of pangs of guilt in all the unanswered email that you have. And I admit I was doing this when I probably should have been answering email. But this is going to be just simply a plot of how much email I send and received at every minute of the day. Right? So take all the days of the last 15 years, superimpose all of them, and just say, you know, at 1:35 p.m. every day, just add up all the emails I sent and received. And we get some kind of a waveform, right? Not quite like Professor Corcom's waveforms, but one that sort of, in a way, corresponds to something going on in my life. So the big red curve is the email I receive, and the lower green curve is the email that I send out. If you don't distinguish red and green, it's just the upper curve and the lower curve. There are a few things to notice. First, that the upper curve is way bigger, which means I'm receiving a huge amount and I'm not correspondingly sending out as much. And you notice a whole bunch of things about the tempo of my life and the way it, in fact, matches the average tempo of many people's lives. You see that not much is going on in the middle of the night. And again, this is local to my time zone. right? At 4 a.m., it's 11 a.m. here, which means not enough of you are sending me email, apparently. But it's very low at 4 a.m. It begins to rise steeply in the morning. It actually peaks around 11 a.m. when everyone, it peaks for, for the rest of the world, certainly. Everybody goes to lunch at noon. There's that dip. Rebounds, comes way down, and then people get back to work after dinner, right? So you see at about 8 p.m., things start to ramp up. And this actually, I'll have you note, is the one moment when I finally catch up with the world. You'll notice that at about 11 p.m., I'm finally sending out about as much email as I'm receiving. I'm finally, briefly breaking even for the day. And I think there's a lot embedded in here, right? This is something you can build very, very easily from accumulated personal data that you have. Actually, I also thought it was sort of informative for a conversation that President Lovey and I were having earlier. Today, you can learn a lot about my sleep cycle, for example, from this, and about the fact that I'm probably not getting enough sleep and that I'm probably exerting myself cognitively much too much shortly before I go to sleep. There are many, many things one might find out. And the prospect of software that might help you make better decisions, might manage your cognitive load, might tell you that you're being inefficient and you would do better to return to this in the morning, all of these are things that I think we're at the cusp of being able to achieve with this kind of data. Again, balancing it against all of the issues around personal privacy. And the other broad question that all of this points to, I think, is the way in which this avalanche of data is causing us to ask questions about the nature of the scientific process. It's really a testament to the robustness of the scientific enterprise that it has managed to scale over the number of orders of magnitude of data accumulation that we've had. It's really an amazing statement about the way science works. But it is certainly also appropriate to ask what changes when we're in this new situation, right? What changes and where the strains begin to show when we're in an era as never before, when we have the ability to measure so much at such high resolution and with such little apparent effort. And these are deep questions that I think all of us across the sciences should think about. So I'll close with my 8th and final picture, basically taking my thank you at the beginning and mapping it using the tools we now have at our disposal. These are all of my co-authors, and these are the co-authorships among them. And again, you can see certainly, I think, parts of my life that I'm immensely grateful to. My graduate program at MIT, so there on the left, IBM at the top left, a large swath of Cornell University, to certain mentors who show up as focal points, just as they did in that Facebook engineers picture, thanks to Dan and Ava and Prabhakar and many, many others who I've worked with over so many years. We see some people, both past and present, from the Technion here, including Sigal Oren, my most recent PhD graduate, an amazingly talented graduate of your computer science program in 2008. And so all of these people, I feel like, have just contributed so much, and it's really just one part of the gigantic fabric of science as it moves forward. And so I think it's this prospect of these challenges and working with these colleagues that draws all of us forward. And in this, to close, I'm reminded of something I heard the writer Joyce Carol Oates say 10 years ago when she came to Ithaca College to do a reading. She was giving advice to young writers, people embarking on a very different kind of collective experience from my own, although similar in a number of ways. And she was trying to emphasize the point that you should only be a writer if you view the act of writing itself, as the reward for all the work that you put in. Right? She said not publication or positive reviews or recognition, but that you should be able to say, this, sitting down to write here today, this is my reward, this activity right now. And I've always felt the same way about the collective endeavor science that I've been involved in, that it's really this experience of finding new scientific problems, getting to think about them, and getting to work on them with such a rich array of mentors and collaborators and students that's made this whole process such a rewarding and such a valuable experience. Thank you very much.